Now we have our part B done. So now we're going to move on to points of inflection, intervals for which the function's concave up, and intervals for which the concave's down. So here, this is analyzing the second derivative. So again, we're going to just take that first derivative, but it's going to be expressed not in that factored form. So we're not going to do quotient rule, because if we do quotient rule, that's typically going to lead to a lot of mistakes. We're just going to take 20 over 2 x to the 3 over 2 minus 5 over 2 x to the minus 1/2. And we're going to start from here. So the second derivative of x is going to equal 60 over 4 minus plus, because I'm taking a negative 1/2 times minus 5 over 2. So plus 5 over, oh, I guess I should write my variables. So 60 over 4 x to the 1/2 plus 5 over 4 x to the minus 3/2. And now I'm going to factor this to get 5 over 4 times 12 x to the 1/2 plus 1 or plus x to the minus 3/2, which gives us 5 over 4 12 x squared plus 1 all over x to the 3/2. And the 12x squared plus 1, we can't actually factor. So this gives us our expression. And what we're looking at is our possible points of inflection. And our possible points of inflection are the numerator. The numerator equals, let's spell that a bit better. Our numerator equaling 0, or our denominator equaling 0. And here, there's no values of x for which this equals 0. But here we have x to the 3 over 2 equaling 0, or x equaling 0 is in our denominator. So our possible point of inflection is x equals 0. Another way to think of that is the critical values for the sign chart, or the important values for the sign chart, is just the value 0. We get 5 over 4, 12 x squared plus 1, and x cubed to the 3/2. Here, this is going to be positive everywhere. This is going to be positive everywhere. We're going to be positive 0, and we don't exist here, but we're undefined here because it's on the denominator. So we're going to be positive and not here. So we're going to be concave up here and nothing anywhere else. So we have no points of inflection. We are concave up from 0 to infinity, and we are concave down nowhere. Okay, that's part C. And now the last thing we got to do is we've got to pull all of what we've done before together. And this is going to be a lot of page turning. Let's just draw our graph. Oh, that's a terrible line. So let's insert a line. And let's insert another line. Oh, first thing we have is we have roots here. And let's say here. And this is going to be root 5 over 2. Then we have at 1/2, we have our horizontal tangent, which we'll say is about here. We have a vertical tangent here. We're decreasing and increasing. And we are concave up, so it's going to be like this. And that's our curve sketch.